Okay, uh, today we're going to talk about derivatives of trig functions, and I want to go through the graphs again of sine and cosine and their derivatives. Uh, so first, let's do the standard labels for the trig graphs. Every pi over 2 on the x-axis, and let's go up. Let's make this 1 and this negative 1 here. Okay. And the first one I want you to graph is the sine graph. Okay, so let's graph y equals the sine of x. Remember, the sine graph goes through the origin. Okay, at pi over 2 it would actually be up at 1. At pi it's back down to 0. So we'd have a smooth curve. At 3 pi over 2 it would be down to negative 1. At 2 pi it would be back up to 0. Okay, and so on. At a negative pi over 2 it should be down to a negative 1. Pi it would be back up to 0. 3 pi over 2 it would be back up to 1. And then 2 pi back down to 0. Okay, so we should end up with a graph similar to that for y equals the sine of x. Okay, then what I want you to look at is taking the slope of the tangent line at the major points. So if we did slope of the tangent line at x equals 0, at x equals 0, if I had this where I can figure the rise over the run and look at the slope of that at x equals 0 would actually be 1. Okay, so on another graph, let's graph at x equals 0 if the slope is 1, so go up and put a point. Okay, and again we're going every pi over 2 on the x-axis, and let's go up to 1 and down to negative 1. Let's go 2 units there. Okay, so if we looked at pi over 2, the slope of the tangent line would be 0. Okay, so on this graph at pi over 2, go down to 0. If you looked at the tangent line at pi, it would actually be sloping. If we figured rise over run, it would be sloping at a negative 1. So this point would go down to a negative 1. So we'd end up with a graph that looks like this. At pi it would go down to negative 1. 3 pi over 2 would be back up to 0. 2 pi it would be at 1. Okay, so and we could do the same thing here. With 3 pi over 2 it's at 0. 2 pi it's at 1. Negative 2 pi it's at 0. So it would be 0. At pi it would be down to negative 1. Okay, and you end up with, if you graph this graph, the slope, if you graph the slope of the tangent lines for y equals the sine of x, you actually end up with the cosine graph. This is the graph for cosine. So basically we're saying the derivative of sine is cosine. Okay, and then you can take the derivative of cosine. Okay, if we take and look at the slopes at the special x values, at, like, if we do the slope at x equals 0, the slope is 0. So if we go another graph, the slope would be 0. So we'd have a point at the origin. If we look at the derivative of cosine and look at a tangent line at pi over 2, that would actually be negative 1 if we figured the slope. So go down at pi over 2, it would go down to negative 1. If you go back up and look at pi, the slope of the tangent line should be 0. So it would come back up to 0, connect those with a smooth curve. And then at 3 pi over 2, it would be a tangent line of 1. And then at 2 pi, it would be back to a tangent line of 0. So this would go up to 1. Okay, and then at 2 pi, it would be back to 0. And then if you looked at this graph, okay, this would end up to be the graph not of sine or cosine, but it would actually end up to be the graph for y equals a negative sine of x. So basically what we've done is we've taken the derivative of cosine, we've looked at the tangent lines at special points, and figured out the derivative of cosine is, with respect to x, is a negative sine of x. Okay, so now we're not going to do that for each trig function, but I want you to put these, the beginning 6 formulas, the derivatives of the 6 basic trig functions. We're going to put these in your notes, and then we're going to actually do an example, and then we're going to come back and create a formula card. Okay, so the 6 derivatives of the 6 basic trig functions. Okay, so derivative of sine of x with respect to x, so x is your angle, we said was cosine. And notice on this our angle is just x. Derivative of cosine of x with respect to x is a negative sine of x. And then the derivative of tangent of x with respect to x is secant squared x. Okay, so those are the derivatives for sine, cosine, and tangent. Okay, then look at the reciprocals. The derivative of cosecant. Remember, cosecant is the reciprocal of sine. The derivative of cosecant is a negative cosecant of x cotangent of x. It's a negative cosecant of x cotangent of x. Then the derivative of cosine is secant. So derivative of secant of x ends up to be secant x tangent x. And then the last one, reciprocal of tangent, is cotangent. So the derivative of cotangent ends up to be, with respect to x, is a negative cosecant squared x. Okay, and those are the 6 derivatives of the original 6 trig functions. Okay. Now, in all these, the angle is just x. If we change the angle to 5x, then that's a different story, and we'll talk about that later in another section. Now, the author is going to give you examples of figuring derivatives, okay, figuring those derivatives, and I'll come back to this page in a minute. When they give you problems to work, they will just say in the directions, find the derivative, and they might say f prime of x, they might say y prime, they might write it, find the derivative of y with respect to x. Okay, let's look at an example. Say they give you the problem y equals sine x times tangent x. Now, what you have to look at is if they are multiplying. If they're multiplying, then it's the product rule. Okay, so y prime product rule says leave the first quantity the same, sine x, times the derivative of the second quantity. So you have to say, what's the derivative of tangent? So you go back and look, derivative of tangent, okay, derivative of tangent is secant squared. So this would be secant squared x. So product rule says leave the first quantity the same times the derivative of the second, and product rule has a plus sign in between. Then it says leave the second quantity the same, so that'd be tangent of x times the derivative of the first. So then you have to go back and say, okay, what's the derivative of sine? And if you go back up here, derivative of sine is cosine. Okay, so then this would be times cosine of x. Now, that is the first derivative. But if you look in the back of the book, that's not what you're going to find. You have to use all the rules that we learned last year on the trig identities to simplify. Okay, so to simplify this, you got to go back and remember, one of the things we did in trig identities was, if all else fails, get everything in terms of sine and cosine. So this sine, I would leave that the same, times secant is a reciprocal with cosine. So this would be the secant squared would be the same as 1 over cosine squared. Then tangent in terms of sine and cosine is sine x over cosine x. Remember, tangent is sine of theta over cosine of theta, times, this would be cosine of theta, like over 1. Okay, and remember, you've got to do your order of operations. So we would have y prime equals sine, this is like sine x over 1. So it'd be sine x over cosine squared x plus sine cosine, sine x, cosine x, all over cosine. Now, to be able to add two fractions together, you've got to get a common denominator. In this case, the common denominator would be the cosine squared x appears, cosine would appear twice, cosine here would appear once. You need it twice in your LCD. So you need to multiply this by cosine of x. You do that in the denominator, you've got to multiply by cosine x in the numerator. Okay, so then we have y prime equals, this would stay sine of x over cosine squared x, plus this would be sine of x cosine squared x all over cosine squared x. Okay, and then you have two fractions with a common denominator, so you can put those together. So you'd have y prime equals sine x plus sine x cosine squared x, and it's all over cosine squared x. Okay, then if you look on the numerator and say what's in common in both of these terms, what's in common is a sine. So factor out a sine, and out of the first term you'd have a 1 left, plus out of the second term you'd have a cosine squared x. And remember, you should be able to multiply this back and get the original up above, and it's all over cosine squared x. Okay, then you look and see if there's anything you could simplify. That is as far as they go in the book to simplify. Okay, and what starts that all out is, when you look at the problem, it is a product. So when you do the derivatives of trig functions, you're going to look for products, you're going to look for quotient rule, and remember, on quotient rule you have to start with the denominator. If they give you, remember, if they would give you something like this, say I gave you a well, I don't think they're going to give you any with the powers yet, because we haven't had that rule yet. So I think you're okay. What you do need to go back and review, you do need to go back and review the 8 fundamental identities. Okay, these are the 8 that we started with last year in Trig, and I think it's important that you get these copied down in your notes. Okay, put them in your notes. For right now, I would not put them on your formula card because I think your formula card is going to be full by the time we get done with the calc. You can use it for your notes as far as reference for doing your homework, but these you should know from Trig. So if you have to, you got to go back and memorize these. First, sine and cosecant are reciprocals. Secant and cosine are reciprocals. Tangent and cotangent are reciprocals. And on these, I've written like cosecant equals 1 over sine. But remember, you can also write that formula 2 other ways. You can write sine equals 1 over cosecant. You could also write cosecant times sine equals 1. Okay. On the ratio identities, tangent is sine over cosine. Cotangent is the reciprocal of that. Cotangent is cosine over sine. Then we did the Pythagorean identities, sine squared plus cosine squared theta. Sine squared theta plus cosine squared theta equals 1. 1 plus tangent squared theta equals secant squared theta. And then the last one of the 8 fundamental identities is 1 plus cotangent squared theta equals cosecant squared theta. Okay. And those you need to get into your notes. You can pause the recording if you need to write those down. Okay. Then after you've paused that and written those down, you need to go back up to the formulas up here, and these will be the beginning 8 formulas. You need to write all of these. Derivative of sine is cosine. Derivative of cosine is negative sine. Derivative of tangent is cosecant squared. And these will be the 8. Now, don't write too large on your card because we're going to fill up probably both sides of this card. Okay. The derivative of cosecant x is a negative cosecant x cotangent x. Derivative of secant x is secant x tangent x. And then the last one, derivative of cotangent, is a negative cosecant squared x. And again, you can pause if you need time to write those down. Okay, and then you should have time to work on your homework. Okay, and then if you have questions, be sure you ask. We will go over things at the next class period.